Hey, this is Math 6, Unit 8, Lesson 6 on histograms. Let's explore how histograms represent data sets. So here's a dot plot showing the weights in pounds of 40 dogs at a dog show. And we can see 40 pounds all dotted away, and there they are. Write two statistical questions that can be answered using the dot plot. Okay, we could say something or ask something like, how many dogs weigh more than 100 pounds, right? And that would be something we could ask. When we could use a dot plot to help us figure that out, and we could get an answer there. We can also find out things like which dog is how heavy is the heaviest dog, or what's the difference between the heaviest and the lightest dogs. Those are all things you could ask based upon that dot plot right there. So what would you consider a typical weight for a dog at this show? So typical weight means that it's going to be about in the center, right? Now the challenging part of this is that what do we see? We see a pretty big spread. So we have a pretty large spread here, which means that whatever we pick for our center isn't going to exactly work for every single dog, is it? Okay? So it depends on what you want to look at, or what you want to consider to be about the center. Sometimes I just do it visually, and I kind of look and say, well, if I'm curving this way, then it looks like my center might be somewhere about here. Okay, and so I might say that typical is maybe 110 pounds. That might be one way of doing it because it looks like to be about in the middle of all the data set there, at least in terms of the spread. Now if you actually counted this up, the actual middle number, middle value, 20, because 40 dogs, 20 is going to be right here at 100. So you can also say it's about 100 pounds as well, because that's going to be the actual middle value of 20 out of 40 dogs. That's where the break's going to be at. The curve makes me think more like 110, but the middle value might be 100. So anywhere in that range is going to be an acceptable answer, because again, you get to decide what do you want to call the typical weight, and that's based upon what you're noticing there. Okay, so somewhere between 100 and 110 pounds is probably pretty typical weight there. So with a dot plot, it's kind of hard to say exactly, because again, it just well, you can say exactly, but it's hard to estimate. There's just so many values there. So here's a dot plot, or sorry, here's a histogram that shows some dog weights here. Each bar includes a left end value, but not the right end, meaning that if you have dogs here, in this bar here, they're going to be between 60 pounds and up to 79. It'll go all the way up to there. Okay? So use the histogram to answer the following questions. How many dogs weigh at least 100 pounds? So at least 100 pounds, meaning that we're going to go from here to here. So first of all, what I like to do on these histograms sometimes is put a little number above it. This bar goes to 6. This bar here goes to about 11. This bar goes up to 14. This bar is lower than 6, so we're going to say 5. This bar is between 4 and 2, so maybe 3. This is between 0 and 2, so we're going to call that a 1. So how many weigh at least 100 pounds? Now, keep in mind, that means you have to count this group as well. This group is 100 pounds as well. 100 is not there. This goes up from 80 to 99, so you have to include the 100-pound group as well. So we would add up 14 plus 11 plus 6 for a total of, did I do it right there? 14, 11. At least 100 pounds. Oh, sorry. At least 100 pounds. Making myself confused here a little bit, working too hard. So at least 100 pounds means we're going to go from here, sorry, all the way to there. So at least. These ones don't weigh enough. So we're going to count 14 plus 5 plus 3 plus 1. So 22 plus 8, 14 plus 8 is 22, plus 1 more is 23, are at least 100 pounds. How many dogs weigh exactly 70 pounds? Well, on a data chart like this, 70-pound dogs are going to be somewhere in that box. But I don't know. With a dot plot, I would know. But here, I don't know. It's an unknown value. I don't know the exact weights of any dogs. I know that there are 6 weigh between 60 and 79 pounds, but how many weigh exactly 70? I have no idea of no way of knowing. Not with histogram, you can't tell. How many dogs weigh at least 100, at least 120, and less than 160. So they weigh at least 120, but less than 160. So you're going from 120 up to there. Well, that's going to be 8 dogs. Weigh between 120 and 159 pounds. How much does the heaviest dog at the show weigh? Well, this again is unknown. We know it's between 160 and 179 pounds, but the exact weight, we don't know the exact weight. We just know kind of the range of weights it could be. Here he is, there's the heaviest dog, he's somewhere in that range. What would you consider a typical weight for a dog at this show? Explain your reasoning. So typical weight, again, you're looking for that center. What would you call the center? And that is what's kind of nice about a histogram if it works out like this. Sometimes you can tell with a visual a little bit more about the center. So I would say a typical weight does seem to be in this range right here, between 100 to 120 pounds. Seems to be a typical weight for most of the dogs. 1, it's the most frequent with 14, and 2, it just seems to be in the middle of the whole group there. So that would probably be a good guess for what those weights are going to be typically. Now I want you to discuss with a partner real quick, which we did a little bit. If you use a dot plot to answer the same 5 questions, would your answers be different? All right, with a dot plot, can you see how many dogs weigh at least 100 pounds? You could probably do that with a dot plot. Can you say how many weighed exactly 70? You could do that with a dot plot. Can you say how many weighed at least 120 and less 160? You could do that. How much does the heaviest dog show weigh? You would know that with a dot plot. And typical weight, you could still do that. So with a dot plot, you can actually answer all those questions there, and you can get some precise answers to answer letters B and D. Okay? So how are they like? How are they different? Well, again, the way that they're alike is they have the same values there, the same spread, and it's just kind of the difference is that this dot plot is going to be much more precise, and a histogram is going to have more of a range of numbers that it represents there. Okay, now that's okay when you're working with 40 dogs, whatever it might be, things you can measure and look at. But let's look at the next question, where suddenly we have more values in a short little space here, and they all are different. So every 10 years, the United States conducts a census, which is an effort to count the entire population. The dot plot shows the population data from the 2010 census for each of the 50 states in the District of Columbia. So you can see all the dots there. Now it looks like a giant blur, doesn't it? Like I can't even see how many dots are right there. I just know there's a bunch between those because the values are very close together. And no one has the same value, so there's nothing going up. A nice dot plot, we kind of go up like this. You can count them. I can count a few values, like a few of these are pretty easy to see, right? Not bad, not bad, not bad. And maybe that one, I think that's 1 value there. This looks like 2 values there. But this mess, oh my goodness, I can't count those at all. There's no way. So here are some statistical questions about population in the United States and DC. How difficult would it be to answer the questions using the dot plot? So we're going to use E for easy to do, H for hard to do, or I for impossible. So looking right here in this column. Can we use the dot plot and figure out how many states have populations greater than 15 million? Well, 15 is right here. So can we tell how many are greater than 15 million using the dot plot? Yeah, 1, 2, 3, 4. That's pretty easy. We can do that one there. Can we tell which states have populations greater than 15 million? Well, do I know the names of any of these states? No, it's just a dot there. So that's going to be impossible. I don't know who that dot is. It's just a dot. How about how many states have populations less than 5 million? Well, 5 million is right about here. Can I count that up and figure that out? Well, on that dot plot there, I'm going to go with impossible because I can't even tell where 1 dot starts and 1 dot ends. That's more than just hard. That's impossible. What is a typical state population? Typical. Well, I could probably kind of make an estimate here. I could probably do that based upon how many dots are over there. I could probably get somewhere close, but it wouldn't be great. That would be a hard thing to do. I could do a typical and say, well, I'm looking for about 25. Here's 4, well, 1, 2, 3, 4, 5, 6, 7. This looks like 8, 9, 10, 11, 12. Probably 25 is maybe somewhere about here anyways. right? So maybe typical is going to be, maybe about 4 million, I don't know. So that's going to be hard. Are there more states with fewer than 5 million or more states between 5 and 10 million? Well, let's see. 5 and 10, fewer than 5. It certainly looks like that, but again, I can't be precise. That's going to be hard. Not impossible, but I mean, this seems like more, but that, yeah. How would you describe the distribution of state populations? Well, it's hard to describe that because they're all bundled together, but I could. It just wouldn't be great. So I'm going to go with hard for that one as well. Okay. Now, if you take the data, population data, and you put it in a table like this where you can see the population values, can you take these values then and put them into a frequency table, which would help you make a histogram? Yeah. So we can count how many populations are between 0 and 5 million. So for example, Alaska is one of those between 0 and 5. Alabama is 1 between 0 and 5. So you can count them up and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So 29 states are between 0 and 5 million. Between 5 and 10 million, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 there. Okay, running out of numbers here. Between 10 and 15, we actually have 3. We have 2 of those, 0 of those, 1 of those, 0 of those, and 1 of those, just to speed the process a little bit there. So now we have a frequency table, and this would help us to create a histogram. So we're going to use these numbers here to make ourselves a nice little histogram of the population. So different than a dot plot, we'll make the histogram. Try to turn my page a little bit here. So between 0 and 5, we go to 29. So 0 and 5, we're going to go to 29, which is right here at that value. I'm going to draw a line for now. Come back in a second. 5 and 10, we're at 15. 5 and 10 goes to 15. And 10 to 15 is 3. And 15 to 20 is 2. None for 2025. 25 to 30 is 1. And then 35 to 40 is also 1. Alright, so now we got to come back and make our bars. So we're going to bring this down, bring that down, 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 and down. This one come down too. Right. And there we go. Now we have our bar graph, our histogram. So now the question is, can we use that histogram then to go back and answer the same questions that we had over here? For how many states have populations greater than 15 million? Well, greater than 15 million, we could look at that and we can look and count and go, okay, we have 2, 1, 1. Yep, we can count that up, right? Easy to do. Which states have populations greater than 15 million? Based upon this, can you tell me which states have more than 15 million? Again, we don't have names there, so that's going to be impossible. How many states have populations less than 5 million? In this case here, less than 5 million is going to be all these. We know that right now it's 29. That becomes easy, doesn't it? Done. Well, the other one was impossible. The histogram, done. Right? Just like that. No problem. What is a typical state population? For a typical state population, again, we can look at this. It's not easy because there's too much of a spread, but it's not impossible. We can get a typical there. So we would say it's maybe a hard. How many states are there? Sorry, are there more states with fewer than 5 or more states between 5 and 10? Well, that's pretty easy. We have 29 there. I think this was 15. We can answer that question by saying more between 0 and 5. That becomes a really easy question, doesn't it? And how would you describe the distribution of states? Well, we could describe it not great, too much clustered here, but again, it's easier. We could definitely say that there are more states that have a small population than large states. They're pretty close together over here, so most are between 0 and 10. So a little easier to describe the distribution using the histogram there, just easier to see. So based upon these numbers, we can see that the histogram ends up with 4 easies compared to 1 easy for the dot plot. Okay, they both have the same impossible question. This one actually has 2 impossible questions. So sometimes it's just better to use a dot plot than it is a histogram. It just depends on the situation and what it is you're being asked to do. Okay, so that is really it for the day. So there is a summary, that's a lot of what we just did here. And they kind of go back to the dog example, the dots, and the histogram, different ways of comparing things, right? The histogram data values are placed in groups or bins of a certain size. So kind of wondering how you get those. You get to pick 10 to 14, 15 to 20, right? You get to pick kind of how wide those ranges are going to be. That helps you out there. So in a histogram and dot plot, they have a similar shape overall. So notice that here, these do kind of look the same, right? It kind of goes up and then drops back down. This kind of goes up and drops back down. So you're going to have a similar shape. You're going to be able to describe them some different ways, but the values are easier to see sometimes in one version than the other version. But it depends on what you're looking for there. All right, we're going to pause there, let you work on your homework, and we'll come back and check it together in just a few minutes. All right, so here's homework for lesson 6. We're going to match these histograms to the dot plots on the next page. Mine's the next page there, kind of annoying. All right, so they match and represent the same data. So here we have a dot plot going from about 5 to 30 with most values between 5 and 20. So where do I see 5 to 30 with most between 5 and 20? Nope, nope, a little too far. Here's 5 to 30, most between 5 and 20. That looks good. I'm going to put A with this one, all right? That works. Check. B, we're going from 30 to 50 with most about 35 to 40. So how do we go 30 to 50? Here's 30 to 50. That looks pretty good right there. Too low, 20, 10, too low, 5 too low. So this one looks good, 30 to 50. All right, next one. We're going to go from 0 to 50. Wow, what a spread. Nothing else has that spread. So 0 to 50. Where do I see that spread? This looks like the spread. 0 to 50. Wow, really spread out. C. All right, and then D, we're at 20 to 50 with most values between 20 and 35. Here's 20 to 50. Here's 10 to 35. So this one here matches that one. 20 to 50 with most in the middle. Leaving us finally with 5 to 40, E, 5 to 40-ish, E, and there we go. So that is our histogram and data dot plots matched up. Okay, so here's a histogram that summarizes the lengths and feet of a group of adult female sharks. Select all the statements that are true. Well, again, when I get a histogram like this, something I like to do is kind of count how many of these are, just so I can kind of visually see. I have 1 there, 1 there. This is 4. I have 10, 10, 9, 10, another 4 right here, and a 1 right there. So it says a total of 9 sharks were measured. Well, nope, because if I add all that up, that's a lot more than 9, right? This is 10, 20, 30, here's 40, and then this becomes 50. There are actually 50 sharks measured, so that is not correct. A total of 50 sharks were measured. Yes, that is true. We just saw that because I counted them up, and that's 50. The longest shark that was measured was 10 feet long. Well, 10 feet long is over here. Our longest shark was between 17 and 17.5, so that is not true. We wouldn't know exactly how long it is, but we know it's not 10 feet, and we know it's more. Most of the sharks that measured were over 16 feet. So 16 is going to be here. So would you say that's a good description to say that most are greater than 16? Are most of the sharks right here in this window? Nope, they are not. So that's not a good description. 2 of the sharks that were measured were less than 14 feet. So here's 14. So 2 of them were less than 14. And indeed, 1, 2, that's a true statement right there. So those are some true statements and false statements based upon that histogram. The next question says, it shows a table in minutes of time it took 40 sixth graders to run 1 mile. Alright, so let's see, how long did it take them to run 1 mile? So here's our table with a frequency table there. And we're going to draw a histogram for the information in the table. We have 4 to 6, 6 to 8, 8 to 10, counting by 2's there. So we can then draw a table that goes this way vertically, this way horizontally. We can have 0, and we can go with, I'm going to go all the way to 14. So 2, 4, 6, 8, 10, 12, 14. So 2, 4, 6, 8, 10, 12, 14. In terms of height, I can count by 2. And, I need to go 16 actually, 16 to get to 14 here, so count by 2's and go 2, 4, 6, 8, 10, 12, 14. Okay, so how many were between 0 and 2? None. 2 and 4? None. 4 and 6? 1. So we're going to go up to about 1 there. 6 to 8 goes up to about 5, so here's our 5 line, so we'll draw a bar there. 8 to 10 is 13, so let's go up to about 13 between the 12 and the 14. 10 to 12, it's going to be 12, so we go to the 12 line there. 12 to 14 is 7 people, so we go between 6 and 8. About here, and 14 to 16 is 2, so there you go. I can put the values above them if we chose to, just to show what those are. And there we go. We have now created, oops, it's sideways, histogram based upon that frequency table there. And finally, number 4, it says that a vertex of one square in a coordinate plane is at -2, 1, 2, and up 1, 2, 3, right there. So that's the one vertex at -2, 3. Name 3 points that could be the other one. We're talking about a square, so a square is going to be the same lengths. So if we say that the center is the origin 0, 0, then I could put a point over here at 2, 3. I could put a point over here at 2, -3, and a point over here at -2, -3, and make ourselves a nice square. And that's what we would say. Alright, that's it for today. Have a great day, and we will see you next time.